This week I will talk about quicksort concept, and second quicksort visualization, quicksort runtime, and finally Python code walkthrough. So for quicksort concept, we have three main principles in order to iterate through the quicksort algorithm. First, we pick last element as a pivot point. As we can see, this is the arrays of size 10, and then we pick the last elements of this array to be a pivot. Second, sort all elements except last. If larger or equal the pivot, then I will be arranged that values to the right side of the pivot, and if that value is less than, it will be on the left side. For this case, since we pick 4 as a pivot point, it go to the right side of value 4, and when we run to 9, 9 is larger than 4, so it will be on the right. 3 is less than 4, is on the left. 1 is less than 4, is on the left. Then we do this so on and so forth until we get a array left hand side and then the right hand side. Then we call quicksort again. This is called partitioning, and then after we sorted by quicksort until left side array and then right side array have an element 1, we will stop partition, because array 1 we don't have to sort anything, it's the sorted algorithm by itself. Okay, moving on. Quicksort visualization. First, find a pivot point. The pivot point in this case is 4, and since the first element of the array is 6, is greater than 4, so it's on the right side. 9 is greater than 4, is on the right side. 3 less than 4 on the left. 1 less than 4 on the left, and then 5 greater than 4 on the right. We do like this so on and so forth. After that, we use the partition array right and left, and then we find a pivot point of each subarrays. In this case, for subarray left is 3, 1, 2. We pick the last element as a pivot point, which is 2, and then the right arrays is 7 is the pivot point. Then we sort the array, and then we get 1, 2, 3, 4, and then the group of 5 and 6, a group of 9, 8, and 10, color coded as red, and then the subarray 5, 6, color coded 6 as a pivot point. Then we sorted it. Then we got as following. The pivot point 10. After we sorted, we have the subarray 8 and 9, which is the size is greater than 1. So we find the pivot point for these subarrays, and then we sort it again. After we have all the subarrays as size exactly 1, we combine together, and the result that we get is the sorted array 1, 2, 3, 4, 5, 6 to 10. Then let's talk about quicksort runtime. So for the quicksort runtime, the best case performance is n log n, and average case performance is also n log n, but the worst case performance is O n square. However, why this quicksort is also popular, since the memory complexity is only 1, and what is O? It's a big O notation describe an upper bound complexity. Okay, now let's go to Python code walkthrough. For quicksort Python walkthrough, first import numpy as np. This quicksort function take an array, and we need to know an array size. Then we can find the pivot, which is the last element of the array. Then we create an array temp pivot, and then we set the pivot index equals 0. Put a pivot to the correct order in an array for index I in range of 0 to array -1. This means that we discard the pivot, but we run to all the elements. Then we check if the elements is less than pivot, then we insert it to the left, but if the value is greater than or equal the pivot, then the elements will be on the right. After that, we partitioning on the left hand side, and then we combine the left hand side back to the pivot point, and then we combine the right hand side back to the original arrays. Then we return the array. For example, the array size 15 and array np.range array size +1, and then we generate a random number. Then the random number is 4x 7 11 5 2 4 15 to 6, and then we call the quick sort that I built, and then now you have the sorted array. Thank you for watching and have a wonderful day.